Okay, here are some sample problems from the pre-lesson without so much explanation. So this is from Try It, number 3A, page 164. They give you this equation, they give you this little clue, and they say, hey, find all the zeros, the real ones and the complex ones. Just so you know, you might have 3 real, you might have 1 real, 2 complex. So just know there's no real rule. Anything can happen. As you can see, though, we only have 1 real in this problem. So we're going to take a stab at it and go, hey, I think x equals 3 as my real solution. So we're going to make sure that's true. 2 times 3 cubed is 27, minus 8, 3 squared is 9, 9 times 3 is 27, minus 9. So this is 54 minus 72 plus 27 minus 9. I'm going to look at the negatives. That's negative 81. I'm going to look at the positives. That's positive 81. We're like, yep. So as soon as I know this is one of my solutions, I know, because the highest power is 3, that I need 2 more. Sometimes I like to go like this, just to remind myself, I'm not done until I find 3 answers. One of them is 3. What do I do as soon as I find one of them? Well, I want to reduce this thing, this cubic, down to a trinomial. That's the benefit of the cheat mode next. Take the 2, negative 8, 9, and negative 9. Remember, if we've done it right, we're going to get a 0 down here. Drop the 2, 6, negative 2, negative 6, 3. 3 times 3 is 9. Look at that, we've got a 0. So this represents, if that's x cubed, this is x squared minus 2x plus 3 is 0. Now, if you can factor this, go for it. Doesn't look like it's factorable to me. So what I'm going to do is I'm going to put that in good old quadratic formula with my a, my b, and my c. So negative b would be 2 plus or minus the square root of b squared 4 minus 4 times a, that's a 2, c, all over 2a, which is 4. Now let's clean this thing up. I'm going to get rid of this. You can rewind it if you need to. So I get 2 plus or minus the square root. 4 times 2 is 8. 8 times 3 is 24. So I really get the square root of 4 minus 24, which is negative 20. You can see imaginary numbers are coming over 4. Now, first thing I'm going to do is take the I out. Second thing I'm going to do is reduce that. Now, this book might get lazy and leave it like that, but I think that's really naughty. So I'm going to go ahead and keep going. So 2 plus or minus, that's a 2i. 2i squared of 5 all over 4. And as you notice, you can take a 2 out of all 3 of those things. So this divided by 2, that divided by 2, that divided by 2 would be 1 plus or minus 1i, or just I squared of 5 all over 2. Now just so you know, the book will probably write this as 1/2 plus or minus I squared of 5 all over 2. This is the same as this, so don't panic when you see a little different variation. Here's example 1. Okay, here's your second example. This is a Try It problem, number 4 from page 165. Now this is just an adjustment to example 4 on page 165, the one I covered in the pre-lesson. Now the difference is the pre-lesson problem just gave you a graph. Then they leave you hanging here. They ask the same question about profits and how many lamps, I think it's lamps or whatever, they need to sell. So it was like, oh, okay, I need the equation, or I need the graph. So because in example 4 they gave us the graph, there's just no reason in my mind why we can't use decimals. So I'm going to go use decimals, and it's going to pop up right here, and we'll talk about it. Okay, so went to decimals, got a drawing just like this. It's a little different looking on decimals. But again, we're not looking for perfection in the drawing. We're trying to answer the question, how many lamps do they need to sell in order to make a profit? Remember, my y-axis is my profit. So I'm only concerned with where this graph is above the x-axis. So I'm not worried about any of this or this I'm just worried about the profit. So we can see there's great profit here in between 1, which is 1,000, and 11, which is 11,000 lamps. So the number X of lamps that I need to sell is greater than, don't put equals, because that would be a profit of 0. Okay, there's no profit there. As soon as I go over my 1,000th lamp, my 1,001 lamp, I start making profit. And that goes all the way until I get up to 11. But on the 11,000th lamp, I'm back to 0 profit. So it's everywhere in between. That's why you're just using strictly these inequalities, not with the or equals. And then you got to think about this. You can't sell negative lamps. So this doesn't mean anything. So this would be my conclusion. Good stuff. Okay. So, problem like this. Solve it. So, first thing we're going to do is set it equal to 0. Now I want you to notice something. This is kind of nice. X cubes are going to cancel. So I want to keep my next term positive. So if I just bring everything over here, I'm going to keep that positive. So I'm going to subtract x cubed, add 7x, subtract 6. Subtract x cubed, add 7x, subtract 6. I'm lining up my like terms. This whole side turns into 0. These cancel. I end up with 5x squared plus 5x, and that's minus 30. All right, is this factorable? Well, first of all, I want something to jump out at you. What can I divide this by? I should be able to divide that by 5. Boy, if that ever happens, you got to take advantage of it. Because look how this reduces this trinomial. So I get 0 is x squared plus x minus 6. And I go, whoa, this is factorable. So factor it. So this, I need a positive 1, so it's going to be positive 3, negative 2, and I get negative 3 or 2. See, some of these, as you just work through it, it'll just spit out your zeros. You go to decimals and check it out. But sometimes it's just voila. Okay. Now, that one was factorable. That's why I'm going to show you the next one. Okay, this one's going to be way different. So here we go. Stick with the program, set it equal to 0, keep your highest powered term positive. So I'm going to add x cubed over here, add 2x, add x cubed over here, add 2x. Now, this side cancels, so that equals 0. And you can notice I don't have any like terms, so you should be in the habit of putting things in descending order. And then we stop and think, is this factorable? And the answer is yes, a little bit, but yes, I can take an x out. So I take an x out, and I'm left with x cubed plus x squared plus 2x plus 2 is 0. Now I'm going to pause a second. Let's go back to something I've been emphasizing. The highest power is a 4, which means you are not done until you have found all 4 of your answers. So with that being said, give me a second. Okay, the reason I paused, I noticed this is giving me one of my zeros, because if I put a 0 in there, 0 times anything will give me a 0. Or, yeah, so I'll just keep it like that. 0, there's one of my answers. Now, I need to deal with this. I'm like, ooh, is that factorable? Like, no. So really nothing I can do. So this is where I went to Desmos.com, looked at the drawing, look, it's a cubic, and it looks like a cubic. I hope you're getting used to that. And it just tells me when I held my cursor right over that point, my other 0 is negative 1. Now, what do I do with that? Well, it's not like this doesn't mean anything, but we've already gotten everything we can out of it. So I want to really concentrate on this. This graph looks like this. This is one of my zeros. So to find the other 2, now how do I know there's 2 more? So I got 2 more spaces, the highest power is a 4. We're going to go with good old synthetic division here. Drop the 1, negative 1, 0, 0, 2, negative 2, 0. Now what does this represent? Remember the rule. We use this, not the original, this. So the 3 drops down to a 2, so it's 1x squared plus 0x plus 2 equals 0. Now, what does that mean? Well, it's the same thing as x squared plus 2 is 0. So if I subtract 2 from both sides, I get x squared is negative 2. Bada boom, bada bang, do the right thing. So I get plus or minus I square root of 2. Here's 2 complex answers. That's what fills in those blanks. And here's 2 real. A little different, but you're going to have a few that pop up like that. Okay, last 2 examples, I'm going to try to squeeze them in, so we only have part 1. I'm going to tackle this one first, 6b, and try it on page 167. Doing this one first, because as you can see, this is easily factorable. So I'm going to factor that into x minus 1, x plus 1. This factors into x minus 3, x plus 2, greater than 0. Now watch this. My zeros are 1 from this one, negative 1 from this one, 3 from that one, negative 2 from that one. Now, this is where the Oreo cookie comes into play. If I go x times x times x times x, I get 1x to the 4th. So I know this is positive, and I know this is even. It's just like the parabola rules. Remember, the 4th is kind of like this, but the end behavior is the same. So I know I'm going to go up from here, and now, because this is a 1 and a 1 and a 1 and a 1, we don't need to be specific here because this is telling us where is the graph above the x-axis. So we know it goes through this one, through this one, through this one, through this one. So my drawing can be pretty bad. And all I need to do now is look for where this graph is above the x-axis. So I can get rid of this. I won't forget that this is negative 1. And I can get rid of this. Where is it above the x-axis? From here, so I'd say x is less than negative 2. In here, x is greater than negative 1, but less than 1. That explains this space. And then this, x is greater than 3. There's my answer for that crazy problem. Let me pause this a second. All right, I'm going to try to squeeze this in. So we start out by looking at this. We're like, hey, got to factor this. So we take a 2x out. Take as much as you can, guys. And then I'm left with x squared plus 6x plus, what would that be, 6 less than 0. You know what that means? When I'm done with my graph, I'm looking for everything under the graph. So, how do I do this? Well, I got to find out where my zeros are. Well, this one's easy. That one right there would simply be 0. Now, if you took the 2 out, you'd say, oh, that's 0. That 2 doesn't really mean anything as far as like finding the zeros. I wish this was factorable. It's just not. So I got to find the zeros of this by using the quadratic formula. Here's my A, my B, my C. I'm going to pause this so I don't waste this time. Okay, condensed. I got 1 minute and 20 seconds. I took this, shoved it in the quadratic formula, whittled it down to this. Now, the square root of 3 is 1.7. I needed to convert that to a decimal so I could actually figure out what they are exactly. Now, you can look at the video to figure out where this comes from, but here are my 3 zeros. 1, 2, and then 3. Now, I go to the original. I see the leading coefficient's positive, and it's a cubic. It means it's going to be like that. I'm worried about the extremities, so it's going to go up like this and down like this. Also, I'm going to go ahead and hold on 1 second. So 30 seconds left. I quickly took Desmos and I checked it out and goes through. Long explanation for that, not going to take your time. Less than 0 means where is it below the x-axis? So no, no. This describes this. This describes this. Boom.